became administrator, developer, architect of this, what I will be this HPC systems. So I know the world from both sides, as a user, and also as a system administrator, architect, and maintainer of these systems. So first, let's look what is the landscape of HPC at UBC and what is the landscape of the outside UBC across Canada. So at UBC, we are running a system which is called Sokai and Chinook. Sokai is our primary computing engine, and Chinook is our storage platform. I will be talking about this as we go. On the other hand, we also have within Canada a very nice, powerful organization which encompasses most of the universities across Canada. And this organization used to be called Compute Canada a couple of years ago. Right now, it's called Digital Research Alliance of Canada. And with Digital Research Alliance of Canada, I'm sorry, this red color is not very visible, but it's not important at the moment, okay? I will be talking about this. So nevertheless, the Alliance is providing multiple HPC sites across Canada, from East Coast to West Coast. In the University of Victoria, we have a very powerful and very nice cloud system. So if you are not an HPC user, but you would like to use some cloud solutions, like platforms, you would like to have a web portal, you would like to have a database which is, let's say, exposed to your research community, then Arbutus Cloud is the place to go, right? Because you can basically deploy your VM setup, set up your web server, and you can basically operate within the cloud universe. In addition to the cloud solution, we have very similar to what we have here at UBC, HPC systems. One is an SFU, which is called CEDAR. Right now, it will be a new system which will be called FIR. Then there is a SciNet, University of Toronto. They are operating a system which is called Niagara. Again, there will be a new system at SciNet as well, which will be called Trillium. Then within Ontario as well, we have a system which is called Graham. And right now, the new system will be called Rockwell. And in Calcul, Quebec, we have Beluga, and right now it will be, sorry, so in Ontario, it's NIBI, not Rockwell. Rockwell is in Calcul, Quebec. And then, of course, smaller installation within the AceNet, so Atlantic Canada. There is quite a lot of systems, and right now, end of July, maybe mid-July, these new systems will become alive as well. So where to start? If you are interested in using, let's say, our UBC system, Sokai, basically the starting point is going to our webpage, reading what is available, how to get access to it, what are the procedures. Pretty easy, pretty straightforward. Basically, your PI has to apply, and then if you can sponsor your access. And we are fully integrated with the campus-wide login. So as soon as you have a campus-wide login, you can log into some other services at UBC. Then you can definitely, without any issues, using the same password, the same authentication methods, you can connect to Sokai and Chinook. As far as description of the system, what is available, how many cores, how many GPUs, what are the quotas, all that stuff is on our documentation page. And that's the second link which I am showing you here. Then as far as the national systems are concerned, the beautiful description, what is available, how to get access is on the Alliance web pages. And by the way, I believe that on a Thursday afternoon, or maybe Wednesday afternoon, we have introduction to Alliance systems as well, given by ARC team, by other members of the ARC team. And again, if you are interested, what is available, how to interact with the systems, because today it's just an introduction, I will lead you basically, that's the beginning of the journey. What we will do today within this hour and a half or maybe two, depending how I am boring, that's only a short introduction. The best practices, what is available, how we operate. But in order to learn, you have to basically start reading very extensive Alliance documentation. Okay? Once again, I am posting where to find this. But if you go Alliance, Digital Alliance of Canada documentation, this will be a first hit on your browser. Okay, so what are the components? I put here HPC/HTC. HPC stands for the high performance computing, and HTC, I will talk about this in a moment, okay? Not now, not to confuse. So what are the components right now currently? This is for UBC systems, this is for all the Alliance systems, and basically all across scientific community right now. This is more or less how everything is built up. These are the main components. So basically we have some storage platform. This storage platform is connected to the compute nodes. So that's so-called the distributed architecture. We have dedicated nodes for people to log in and do the interactive work. We have dedicated data transfer nodes to move the data around. Again, on Thursday afternoon, there is a session, introduction to Globus. Also, we have all of you are invited. What is the essence of this distributed system? Is this what is in the middle? This is this fast interconnect. And nowadays, still the golden standard is so-called InfiniBand. Incredibly low latency, incredibly big throughput between compute nodes to compute nodes, between compute nodes to the storage, between compute nodes to the data transfer nodes. All that it's incredibly fast interconnected. And that's for quick I/O, as well as you are doing HPC, which is a parallel computing. This is the multiple nodes involved in a single simulation. These nodes have to communicate with each other incredibly fast. Compute nodes, in essence, this is very beefy laptop. But your beefy laptop doesn't have this big storage, and your beefy laptop doesn't have this fast interconnect. You can talk only to your laptop. So that's where the main difference is. Now, if you logged into, right now we will start talking about the storage. So when you logged into to Sockeye or any cluster available to you within the landscape, which I was just drawing for you, you will see, and today Jacob was already showing into an introduction to the bash scripting, to the bash command line and scripting. You will typically see this file, this structure of files. So you will have your home, you will see your project directory. On many systems within the Digital Alliance, you will see Nearline and you will see Scratch. Now, what is home? Home, as it says, only you own this, what is inside. So this is a good place for storing your paper you are working on, your thesis you are working on, the programs you are developing, something which you don't share, which we would like to have this private. Project, that's where you collaborate with your group, okay? We are working on the same data set, we are working on the same project with different angles. So in project space, you will put all the process already data which you are collaborating with and you are sharing within your group, within your project. Nearline is very similar to what we are offering at Chinook, and I will talk about this in a second. And Nearline is usually a kind of a long-term storage, which is tape-based, but you still have the access to it via command line. You can still see this file system, but it's more geared for the long-time archiving of the data, okay? Because moving the data back and forth from Nearline is slow, okay? Because you have to reclaim from the tape, then it has to be moved somewhere else. So that's a long-term storage. Scratch file system, this is where you do all your computation. Okay, you can read the data from project, you can read the data from home, you can read your executable from there, but whatever you are producing in terms of the I/O, this goes to the Scratch. Why? Home and project are being backed up, so your data is always safe. We always have multiple copies of the data in case you somehow by accident erase this or remove them from erase or remove or move somewhere where you don't have access. These file systems are being backed up, home and project. Nearline, since this is a tape, this is a reliable, robust, with multiple levels of protection, but in essence, that's only one copy. Scratch, because we need Scratch to be fast. We need quickly read, quickly write. Scratch is not being backed up because then if we will be doing the backup, we will never finish this backup. And we will slow down the I/O and whatever we are trying to do. So Scratch is volatile. If you erase something from Scratch, it's gone, okay? You have to have the ability to reproduce this. So there is no backup for Scratch. Now I will be talking about these quotas and these inode numbers later on. That's just right now the introduction of where we are, okay? How the structure looks like. Now, Chinook is slightly different, once again, because Chinook is an object storage. So what is the, sorry, I'm going here. So what is the main difference between a file system, file storage and object storage? In a file system, as you can see here, Jacob was talking about this as well. I just mentioned about this structure. In essence, this is a very beautiful ordered directory type, file type stuff. Chinook is an object store, which means that when you logged in to Chinook, basically you are connecting to your bucket. And every file which you are putting is sitting in this bucket as an object. And in essence, when you are sitting on Chinook and you see these objects, this data, you cannot interact with this data. You only know the metadata. Okay, there is no ability within the object store to look at the data. You can only have the access to the metadata. In order to work on that, you have to move them back to your laptop or back to the computational platform where you can process this data. So far, so good? No questions? We are going? Okay, good. Okay, the other layer behind the storage, okay, I logged in, I moved my stuff around, and now I would like to compute. So what do? I need software. Okay, on your laptop, you know, you have installed or pre-installed something. In here, you have to find what is available. So again, you can always install your software on the HPC system. You don't need root privileges because you have access to your home and you have access to the project. So if you are sharing some software, you can install this in the project. If this is a software which only you are using, or you invented, you wrote this code and you don't want to give anybody access to it, it's mine, you will keep this in home. If you are collaborating, you can do this in project. The only caveat is that most of the HPC systems in the world are operating Linux operating system. Okay, so your software has to be Linux aware. Okay, if this is something which is running only on Windows, then your only solution is Arbutus Cloud, where you can basically deploy a Windows machine, right? A Windows VM, and then when you are computing. However, so you can always install your software. However, even to install your software, you will still have to know what is installed globally on the system. Because installing your software, you would like to use some kind of a compiler, maybe, right? Or and there is many of these different compilers, and you can have some preferences. When you logged into the system, for most of the systems, as far as I know, this applies to it applies to Sokai, and this applies to all Digital Alliance systems. We are using this module utility. Okay, so that's a very nice piece of software which allows us to present to the user environment which they want. Okay, so and right now we will be talking about these modules, right?
Roman, there's a question on Slido.
Mm-hmm.
So. I'm just going to read it out for the people in Zoom and also for the people who are in the room. So the question is, does object storage systems store the files in that weird, unreadable language to humans? However, computers can understand it. Is that what metadata is?
Yeah, so going back to this object store, there will be a very nice session how to use Globus. Chinook uses two different protocols, Globus and S3. When you are using S3, yes, that's weird. However, Globus will present you this as a very nicely stored data. What I mean by metadata is basically the description of the file. Okay, so I know the size of the data. I know what is the name of this file. I know what is the modification time, who owns that file, what type of the file it is. But I cannot look at it when I am logged into the object store. I have to try to pull this back and forth. I'm pushing this to the object store to store it. When I would like to operate on this file, when I would like to, let's say I am putting a set of images from your MRI machines there, and I will store all these images on the object store. When I logged into the Chinook to the object store, I know what is the name of the image, but I cannot look at the image. If I have this on, let's say, Scratch file system, I already have the access to the software, right? So I can use an image viewer to take a look at this image. On object store, there is no software installed, right? That's a pure data. So that's the main difference, okay? So coming back to this modules, so Chinook is using, Sokai is using modules. and all Digital Alliance stuff, the HPC systems clusters, they are using also this modules utility. And typically, what is happening, basically, these modules, that's the hierarchy, these are the layers how everything works. So there are sometimes very independent programs which are basically, installed there. Okay, so this is the first layer. The programs like, let's say, Gaussian or GROMACS or something which is basically totally independent system agnostic type of the software, okay? It's basically Linux. I have a binary, and I have a software installed for this, and I will have a module for that. Then, of course, if I am starting to build some software, I need the compilers. So the second layer of the modules is different type of the compilers. Okay, sometimes when you are installing something, they are telling you, oh, you need to use Python interpreter. It's not a compiler, but interpreter. But let's say Python version 2. Okay, because our software is built around Python 2. We will have a module for Python 2. If you need Python 3.2, we will have a module for Python 3.2. Sometimes even with the GNU compiler, GCC or G-Fortran or G++, some pieces of software, some code which you need to compile is tied up to the specific version of the compiler. Okay, we will have them. And that's another layer. Now, since we have this layer of different compilers installed across the systems, then we can also build compiler-dependent programs. Okay, I can build, let's say, GROMACS with Intel compiler. I can build GROMACS with GNU compiler. Or I can build some other piece of software using NVIDIA compiler. Okay, so that's another layer. Then the next layer is MPI implementation. MPI stands for Message Passing Interface, and that's what is the essence of HPC computing. In HPC computing, you are working with the multiple nodes, and these multiple nodes have to communicate with each other. And the best way to use this communication layer is using MPI. And of course, then, well, there will be an MPI-dependent programs, right? I can have an open MPI version 5, or I can have an open MPI version 4.6 or 4.1, whatever, right? And this is recommended MPI layer for this type of software. I can build these programs, then using the corresponding MPI compiler, right? So in essence, okay, I'm loading, let's say, GCC compiler, then I am loading open MPI compiler, open MPI software, and then I can produce my executable using this kind of modules, right? Now, how do we navigate with within the modules environment? When you logged into the system, you can always type a command module list. The module command is always in your path, okay? We will make sure that this is when you logged in, you have access to this structure of modules, right? Module list lists you what you have currently loaded. Some systems, let's say Sockeye, by default, doesn't give you anything. If you logged into Sockeye and type module list, you will have the output. Modules are no modules loaded. If you logged into the Alliance systems, they are a little bit more, maybe not a proactive, but these are the kind of the policies. They basically they prefer some kind of a default environment which you will be using. So they are defining your defaults. So when you logged into let's say, Graham or any systems within the Alliance universe, and you will type modules list, you will get the list of modules which are already preloaded for you. Okay, and now if you would like to clean your environment, you can always use command module purge. Okay, it will purge all your modules. And modules list then will show you nothing is loaded, okay? If you type modules available, it will list what you can start loading out of these 5 layers, right? So if I will say module available, I will see most likely first of all, these independent programs, which are totally independent of the compilers. Then then I will see the list of the compilers, and I will see the list of some other modules, right? So if you are not sure what is loaded, in the documentation pages, we are describing what software is installed, but you can, let's say you are interested in, I don't know, GROMACS, right? This is a piece of software used by chemists for the molecular dynamics simulations of the chemical systems. Okay, if I will type module spider GROMACS, we will go through all the lists of the compilers, we will look around, and we will spit you, the system will spit you what version of GROMACS are available. So use the keywords to look for the software you are interested in using. And this module spider and these keywords will give you what is available, what are the choices, what is matching. And of course, it will then give you all the dependencies which you have to use to load this particular module. So as soon as you will find your modules which you would like to use, module load, module 1, module 2, module 3, module 4. Boom, your software stack, your software layer at this moment is available for you. Okay. Next step. You have your software using the modules command, or you build your own. All these HPC systems are shared system. So we have to use some piece of software which basically will manage all our resources. After we manage all our resources, and we will need a piece of software which will schedule these resources depending what you want. Right? Because let's assume that I am a very savvy computer user. I know how to utilize all the nodes, and I will request from this HPC system that I would like to use 3/4 of available resources for my big parallel simulation. If I am this one user who is taking all these resources, and there is some other people who would like to compute, they have to wait because I am computing at the moment, right? So this is the part of scheduling and resource manager. SOCI and all the alliance systems are using Slurm utility. This is a piece of software, it is called Slurm. It used to be simple Linux utility resource manager or something like that, okay? It's not any longer simple, so they decided to drop all the capital letters and start talking about this as a Slurm, just Slurm. So Slurm is a resource manager and a scheduling platform, okay? For SOCI and alliance systems, the main factor in the scheduling policies is the fair share factor. So we are trying to be fair to everybody. The more you use, then the more you wait. But this is a learning curve. You will have to basically learn this.
So everyone, we have a question in Zoom. So the question is, can you explain and dive an example of when do we need to use an HPC system and what are the benefits?
When you would like to use HPC system, so there will be the second paradigm, this HTC, which I will start talking about this in a moment. But pure HPC stands for high performance computing. your data doesn't fit your desktop or your laptop. You need to process, let's say, a data set which has 1 terabyte of, is taking 1 terabyte. It doesn't fit your desktop. You need computational power of not 16 cores, which you have on your laptop, or 32 cores, which you have on your desktop. You need 200 cores, or maybe 600 cores. Then you go to HPC. And then I will, in a moment, I will be talking, I will answer this question when we will start talking about the HTC, because that's the most compelling argument why to use these systems, right? When you are in the HTC universe. Because how many of you are, okay, no. Let me follow the rule, okay? So let's finish about the Slurm for the moment. So what is the first step of using Slurm and running on HPC system? You have to create a Slurm job script, okay? And the first line is basically the shell in which you will write your script, okay? So that's what Jacob was talking about today in the morning. Typically, the most popular stuff of scripting is just basically bash. Okay, so we will write what we want to do in bash. Then all this, this segment where you have this hash and sbatch, these are the directives to the schedulers, and they are describing what do you want. So in here, what we need to specify, these are basically the arguments which should be in your script, is basically how long I would like to compute, right? Because for effective scheduling, I would like to know if your code will be running an hour or 1 day. The second line is how many resources do I need, okay? We have multiple nodes, and now I am telling to the scheduler that I will only use a single node simulation. I will use only one node. So that's sbatch minus nodes equal, okay? Then how many cores within this one node do I need? That's the third line. Sorry. That's the second line, sorry, the third line, mem per CPU. So let's say I would like to, and I'm asking for CPUs per task equal to 4, right? So I am asking for 4 cores, this per node. And then this line, memory, how much memory per core do I need? So my total memory will be a multiplier of number of tasks multiplied by the memory per task.
There's a question on Zoom. So the question is, so the hashtag sbatch line are not common?
No, sbatch is not a comment. It's a comment for the bash script. But since Slurm will be reading this, it's a comment line. If you execute this, it will just spit whatever is. So if I will execute this script, like Jacob was showing today, that I will change the permission that this is executable. When I execute this, yes, this will be a comment. But I am submitting this to Slurm, and Slurm treats these comments as a directive. So anything which starts with the sbatch is read by Slurm to deploy your code. And of course, then there are all the other options, how your accounting name, where you would like to put the software, where you would like to put your output, input. Yes? The nodes is simple. That's how many physical nodes do I need? Tasks, task in MPI language will means how many MPI processes I need. But in here, it will, in this particular case, it will mean how many cores I would like to have on within this one node. How many cores do I want to? Okay.
So there's a question on Slido. The question is, do I need to type in sbatch./your executable, or may I
Someone
type in?
saw my slides before. There's someone saw my slides before, because that's what I will be doing in a second, okay?
So I'm going to finish off the question. So may I type in /your executable in a terminal and have sbatch as the first line in the script?
Here we go. But let me finish about this. My first comment will be sbatch job sh, okay? So as I said, in this job script, that's a comment, but these comments are written, are read by Slurm, describing what resources I would like to use. And then that's my typical script. I am saying, load these modules for me because I am dependent on them. List them so I am sure that I am using correct modules. And then I am typing, execute my stuff. Execute my code, which I have written, and I am exiting for that. That's what I am submitting. And so now how do I interact with the scheduler where I have software and I have job submission script? Right, so on prompt, I'm navigating to the directory where I created my script. So Jacob was telling you how to navigate there. You will find your way when you read the documentation and practice. This is a journey. It's not that from the very beginning you are a competent user of HPC system. There is a little bit of learning curve, but I'm telling you this is maybe steep, but as soon as you will get to some level, smooth sailing, okay? Then you are just basically computing.
There's a question on Slido. So is there a unit for days when we define the job length, or should we just increase the number of hours? For instance, 72 hours for 3 days.
You can use any units. Once again, documentation tells you that you can use either 72 hours or you can say 3 days. Okay, that's very flexible, wall time requested can be written in a quite flexible format. So how do I interact with right now the scheduler? These are the typical commands which you will have to, Slurm used to be simple, but right now to every of this following command, there are multiple options, multiple formats. Documentation is the best way to look what is the most flexible or most pleasant output. So which options to use to do SQ, please read the documentation. So SQ will list you the list of your jobs which you are running. Slurm priority will list you the jobs in the list of the priorities. So you can always take a look who is ahead of you, who has a higher priority of the job, right? S-control allows you to query the running jobs or pending job. Look what is requesting. For the finished job, SF command tells you that's a Slurm efficiency, so how efficient your job was. Finally, SS share will give you how much resources you have used. So let's assume that you are working within a bigger group and your jobs are not running. Your jobs are not running because maybe someone from your group is already running and they are using most of the priorities assigned to your group. So SS share will give you the view. Where are you within your group? Where are you within all the other users of the system? Again, beautiful on the Sokai pages and on the Digital Alliance pages. Okay. So right now we are coming to this kind of a section when we will talk about why to use HPC, what are the benefits, and so my question to you, okay, sorry. So the definition of HPC, high performance computing, This definition is well established and basically tells you tightly coupled parallel jobs communicating between the one node to another, exchanging the data, requesting multiple nodes, and using MPI. So my question is, who from the audience right now is an HPC user? Okay, you can go home. There will be nothing interesting for, no, maybe there will be something interesting. But nevertheless, out of this room, we have 3 people who are using HPC. So why you are here? Most likely, you are here because you will be so-called HTC user. And HTC stands for the high throughput computing. Okay? So high throughput computing, that's the more or less, once again, well-defined definition. Then in essence, I can compute on my laptop or on my desktop in the office. However, I would like to, if I am using my laptop, I can only run 1 simulation a day. Okay, I am turning this simulation to run on my laptop, and I can go for a coffee, I can go for lunch, I can go, and then I'm coming and it's finished. But I have to complete my project, complete my thesis. I have to run 10,000 of these jobs. So using my laptop or using my desktop, I will spend 1,000 days just computing. But if I am going to the HPC system, which has 500 nodes, like Sokai has a 500 independent computing nodes, and I will use a day 100 of them, I am cutting my time by 10. But then there are other resources which I don't have to use 100 jobs, I can submit 1,000 jobs. That's high throughput computing, and that's why it's interesting to start moving to these platforms, because I can finish my program, I can finish my research faster, okay? So that's what it is. Oof. Okay, let's go. Okay. So right now, let's go to this realm of the best practices and how to construct, what are the best practices when I am using, when I'm HPC user, when I'm HTC user, I am a user of distributed computing clusters, right? What are the best practices? What is the best way of behavior? In these systems, you are sharing everything, okay? You have your home, which you are not sharing. Everything else is shareable. So if you are on the login node, most likely on this login node, there are other 100 users, depending on the size of the systems they are being logged in. So if I will start running very, very long code on the login node, taking all the resources, I am slowing down everybody, right?
There's a question on Slido. So the question is, if I have multiple Python script needing the same resources, should I submit them as a separate Slurm jobs, or can I combine them into one .sh file? So
for this question, the answer is very simple. You can basically submit as many jobs as you want, or you can take a look at the utility, which is called job arrays. Again, job arrays, very well documented, and I believe that I will be talking about this as well in a moment.
There's another question. So if I had 200 jobs to submit, is it all right to submit half to one cluster and the other half to another?
Yes.
would it lower the time in queue? What do you recommend?
That's correct. Right? You know, divide and conquer. Divide and conquer. So submitting to multiple clusters, distributing my load, definitely will maximize the access to resources. Definitely, that's one of the strategies that one members of the group are running on, let's say, CDAR system. The other part of the group is mostly running on Graham or NIBI or Rockwell. That's a typical one. So, but coming back to this, that everything is shared, right? So we share the login nodes. We share the data transfer nodes, because if I am doing the data transfer from one place to another, of course, multiple users should be. So sometimes your transfer is a little bit slower because there is too many data transfers, right? So be patient, because that's a shareable resources. The data transfer nodes are shareable. Compute nodes are shareable. The GPU nodes are shareable. And of course, we are all sitting on the same network. And we are sitting on this stuff, you as a users, and the team on the other side who would like to make this system as agile, as dependable, as fast as possible, right? So, and please remember, that's not a war between us. This should be a kind of a collaboration, finding the common ground together. So, when I was showing this picture, however, I think what are the main components there? Right now, in here, I am saying what you see as a user, right? And that's what you don't see, okay? You don't see all this management layer built by us to provision the nodes. You don't see how scheduler is working, because it's sitting on a separate node, because effective scheduling needs quite a lot of resources. So we are not putting this on a login nodes. We are putting this on a specific special node. You don't see the servers which are working hard trying to fetch your data, transfer this data. You don't see that, but we have to make sure that this file system serving nodes are operating at full capacity and they don't have any issues. And of course, you don't see this entire provisioning layer and monitoring layer, which we need to use to make sure that the system is operating correctly. And of course, you don't see the hardware which is operating the network. Again, we have to make sure that the network is reliable, that there is no bad cables, that there is no bad ports, that everything is operational 100% all the time. And that's a tough job. So as again, that's not a fight. All of that is shared, but it's very easy by one user or a group of users to impact performance of the system. And please remember, if you are impacting the performance of the system, you are impacting yourself, you are impacting the other people who are using the system, and you are making us a lot of troubles because we don't know exactly what to do. Should we terminate your job? Should we talk to you? Right? It's a tough kind of call. Very often, you know, if this is late night, very often it will be just cancellation of the job, short email. You are abusing the systems. Please talk to us and stop doing what you are doing. But so that's what I am asking, that in this, when you start using this, yes, I would like to compute as much as possible. I would like to compute as much as quickly as possible. But please remember that you are sharing this with someone else. And you are affecting, if you are not doing this correctly, you can harm yourself. You can make life of the system administrators miserable, and all other users really, really unhappy. Okay, so the best practices. If login nodes interactive work, lightweighted, editing, scripting, short testing jobs up to a few minutes, not anything big, not anything which takes a lot of resources. For this, use specially dedicated interactive nodes. We will have a session, very interesting session given by Jacob on Thursday, when we will be talking on open on demand. And this is for this kind of interactive kind of a work, heavier than normal. So login nodes, lightweighted. If you would like to move the data, don't use login nodes because they are not tuned up to that. They are tuned up to logged in, submit, do the editing, do the testing, and submit the job. If you are doing the file transfer stuff, use the dedicated data transfer nodes. Compute nodes, I also shared, so when you are writing your job script, we will be talking about this in a moment, be also kind of, let's say, effective. So if you know that you can utilize that your code needs only one core and 5 gigs of memory, ask for that. Don't ask for one node, 30 cores, and 100 gigs of memory, because you don't need that much. But since you requested these resources will be assigned to you and will be not usable to anybody else, right? So be very precise in what you are asking for. And then basically don't, if you are doing this kind of the special nodes which are interactive, once again, testing, something short, don't hog the resources for a long time. Okay, so that's what I was, okay, I missed this. So as I said, interactive session, editing, compiling, short testing, if there is something longer, as batch this, do this as a batch environment. For the data movement, use the data transfer nodes. And the best way to transfer the data, there will be a beautiful presentation given by my friend Michael Tang in a couple of days, and Ben Lee, who will be talking about the globus. Okay, how to effectively, nicely, using either GUI or command line, move the data between your lab, your desktop, or your lab to any of the HPC systems within the Alliance or UBC realm.
What are the access to more cores that are available on a single node? And suppose you actually like data source, is there a software that lets you sort of data between orchestrate experiments?
The Scratch file system is available everywhere. So if I am on a node 1 and node 2, Scratch is exactly the same on the compute nodes 1 and compute node 2.
So you're saying
you have access to the same data all the time.
Right, but disk I was like that's the fastest we can do. Because like writing to Scratch is disk I.
Yeah, okay. Definitely. MPI. You can send the data using MPI, but if these are the file access, you are for creating a file on this node and reading on the other one, no problem.
Say like it's temporary computation, like you don't necessarily want to like MPI would be
yeah. Mm-hmm. Mm-hmm.
Could you repeat a question for the remote attendees? Are you able to say what the question is?
Basically, using the multiple nodes, reading and working on the same data. Yes, that's possible. Multiple solutions, but yes, this is possible. Okay, so I'm right now going once again to the slide when I was telling you when we started to talk about the storage. how we should be interacting with these global file systems. And right now, I would like to talk about this second and third column, right? So if you logged into since this is shareable resources and they are limited, on most of the systems, not on most, on all of the systems I know, in order to maintain sanity and prevent the situation that out of the blue someone cannot create any longer files because the file is full, because someone has used too much. Most of the systems are introducing something which is called quota. And there is a disk space quota, and there is another type of the quota. Since these are the big parallel file systems, they are tuned up for big files. There is a quota for the number of files you can store within your home, within your project, and within the Scratch directory. On the Sockeye, we have the utility which is called print quota. On the Alliance systems, I believe this is the disk report command, which will give you what is your quota, how far away you are from your limit. So again, when you logged into Alliance systems or when you logged into Sockeye to NHPC systems, there is a documentation which tells you what is your allocated disk size and what is your allocated number of inodes. On Sockeye, we have a special file system where we can basically give you unlimited number of files. We have a limited number of disk space, but we have unlimited number of files. So that's, once again, read the documentation, and if at one moment it seems that you can, when you are trying to create a file and you are getting a comment, no space left on the device, it doesn't mean that you have used all your space. It's also possible that you have used too many files within your file system. Okay, so always pay attention to your disk space and the number of files which you are storing within this directory. And let's say object store Chinook doesn't have the limit. Okay, so it can be 5 million, 10 million, doesn't care. Okay.
So there's a question on Slido is, can we request an increase in the disk space quota?
You can always ask if this will be granted. Everything depends, right? So we can always ask, yes, I need more files, but then most likely if I am involved, I will ask why. And if I will hear the answer, because I need more, I will ask again why. And then after a couple of whys and couple of explanations, we will come to some conclusion and some kind of a compromise. Because this is not extendable, right? There is a limit on everything, right? So if you need 100 of petabytes of storage, impossible, because we don't have 100 of petabytes. We have 100 petabytes for everybody, but not for a single person, right? So that's again, there will be a very talk, introduction to the Alliance systems. It will be given by Venkat and Michael. I believe it's Wednesday. Check the schedule, when they will be talking about the Alliance systems, how to navigate in this, what are the best practices, how to navigate, how to ask what to apply. As far as we are concerned, UBC ARC team, we are open for discussion. Please come to us, talk. And we are also a part of the Alliance, so we are also involved in all these other discussions, and we can advocate on your behalf. Okay.
Another question on storage. So the question is, I was wondering with storage, do you personally back up your data on your own external drive, Or do you trust that the nearline in project is reliable?
No, you can trust for nearline and you can trust the project. This is a very reliable backup. Okay, you don't need, unless you are paranoid, but as far as I know, so far we haven't within Alliance or even Compute Canada, there was one small issue where we lost some files on scratch because we don't have backup, but we never have lost any data which were on nearline, or project, or home. Okay, it's never happened in the history of, as far as I remember, and I am in this business almost 30 years. Okay, so yes, that's reliable. That's a reliable. Yes, you can always store this, an extra copy on your desk, on your external drive, but you can trust the data on these platforms very, very strongly. Oh, sorry, because I didn't. Now, how to interact with the FS when you are with the file system, when you are basically running a simulation, right? Since it can happen quite often that we have some hardware failure, the node fails. When the node fails, your entire simulation running on this node fails. So you have to restart your simulations. And if you are restarting your simulation, it's always good to restart not from the very beginning, because if you are restarting from the very beginning and the system is a little bit older and unstable, it can happen that every time you submit another node which will fail. So use this so-called checkpointing facility or utility. So construct your code this way that periodically, when I am running my simulation, periodically I am stopping the simulation and I am taking my entire simulation checkpoint. Okay, so I'm in this point of time, I am creating a file that when the job doesn't finish or it needs more time, I can basically restart from this point. Okay, so it's called checkpointing. Read about this, learn about this. This is incredibly important practice in the HPC environment. When you are developing some piece of software, you would like to see the progress, how everything is running. So very often when you're running this on your laptop or on your desktop, and that's an interactive kind of a work, you would like to see the progress of the simulation. So you are printing a lot of logs messages. Okay, I did this, I did that, I am at that step, right? And it's spitting all the time something to the screen. When you are submitting a job which is doing this excessive logging, you don't have a screen. This is in a batch. So we are writing this to your Scratch directory. That's where we are running simulation. Okay, that's where we are doing this. Writing to Scratch is a network operation. So I have to contact the metadata, ask of where I have to write, go to this disk, write, confirm with the metadata, and confirm to the node when I did this already. So when you are doing this excessive logging, you are slowing yourself considerably because you have to do the I/O, and I/O is expensive operation. So as long as you develop your code, don't write, oh, I did the iteration 1, iteration 2, iteration 4, and this goes every second or even millisecond, okay? If everything is already nicely developed, write this timestamp that I completed this timestamp every 1,000 steps. You will run faster. So don't use this excessive logging or verbosity of your program. As long as the code is developed, go with the verbosity to 0. You will run faster. That's a good practice. If you are creating, if your code is a little bit clunky and needs a lot of small files, plenty of them, again, writing to the global file system is expensive operation. will slow the entire file system responsiveness, will slow your code, will slow running everybody around. But every compute node has its own disk. And typically right now, nowadays, this is SSD, this is a solid state drive. It's not a spinning disk. So it's very, very fast because that's a local to the node. And it doesn't have the limits of this quota. I can create 1 million files on a local disk. And I absolutely don't exceed my quota. So if I am writing the small temporary files, which are very often unnecessary when the simulation is already done and finished, use this utility, which is called, use this local drive, which is accessible by the environmental variable slurm tmpdir. Okay, when we configure the slurm, we are always pointing this variable to the local disk. Again, beautiful documentation on Sokai, how to utilize this, how to preserve some files, and when they are done, move them from tmpdir to back to scratch. And similarly, there is quite a good documentation on the Alliance systems. However, if you really need these files all the time, don't hesitate to talk to the support, because let's say on Sokai we have a so-called arc burst file system, and this is available on all compute nodes, but these are all SSDs. We have no limits on the number of files. So please talk to us that your software needs this. We will meet and we can allocate you this special dedicated type of the file system for this type of simulation. And exactly, when you are not sure, please talk to us, okay? Either open a ServiceNow tickets, which will open a ticket with our team, Arc support, or open this with the Alliance systems. Again, this is, we are also a part of this, so we will be looking at this ticket as well. Okay. Okay, so we already talked a lot about these modules. Within your scripts, always use this module utility as well. So we are basically, when we are trying to diagnose the problem, we know exactly which modules you are loaded, what is your fabric of your batch job. So if there are some kind of problems, failures, we know immediately where to look. And that's a good practice to list the modules which you are using, because you can load your modules in the bash RC as well. But it's a good practice to have them in a job script. Which modules are loaded? So list in your job script, use the module list command, okay? I am saying that that's very useful to diagnose the problem, okay? If you have this line. And when you are working on a new piece of software, remember that when you submit a job, if I have a module some loaded before, it will be loaded within this job script because Slurm inherits your current working environment.
There's a question coming from Slido. So can you further explain what do you mean when you said that when we redo simulations?
No, it's not a good idea to start from the beginning. That's why we're using checkpointing. The idea of using checkpointing is the following, that we are not starting our simulations from the very beginning. We are starting from the checkpoint. Absolutely, okay? No, never redo, always progress, okay? Never go to the zero. Okay, now what are the best practices, the best kind of a behavior when you are working with the scheduler? Okay, SQ command lists you the number of jobs which are right now currently within a system. SQ minus T running lists you the jobs which are currently running on the system. SQ minus T running minus U and my username will list the jobs which are running currently on the system. SQ minus T pending minus U, my username, will list me the jobs which are currently in a state pending, so they are waiting. And now, very often, I have seen users who are so eager to know how many jobs are running and how many jobs are pending that they are querying the scheduler every second with these two comments. Every second there is a query, it's written somewhere in the cron, or basically they are using this utility which is called watch. And every call like that is a call to the scheduler. If everybody is doing this, then the scheduler will choke. So don't do that. Okay, if I'm running 100 jobs for a week, if I will be watching this every 2 seconds, it will not change from 100 to 0, okay? I am not saying that don't query the scheduler, but be reasonable when you are querying this, the scheduler, how often you are doing this. Okay, because this will make it easier for everybody else to query the scheduler. Because if everybody will be doing this, you will type SQ minus T running minus U, my username, and there is nothing. There is no output. It will come in 5 minutes. Because everybody is doing this, right? So, you know, this kind of a, be gentle, okay? Be gentle, be nice, go for a coffee. Then to come back and type SQ. Again, good practice. So don't submit zillions of jobs. If they are running all a week, don't submit zillions of them, submit reasonable amount of jobs. Because, okay, scheduler, when I am going through the scheduling cycle, I have to go through the entire queue to make sure, because I am using backfill, different facilities to schedule as effectively as possible. And if the size of the queue is huge, it takes me time to pass through this list. And these systems are quite big. There was quite a few users. Typically, let's say even on Sokai, which is only for the UBC, and it's a small system, we still have every day something like almost 100 active users, right? So that's on a daily basis, we have 100 users. On these bigger national systems, this goes into the thousands, right? So be, let's say, effective. Talking about the wall time and the resources requested. Wall time, typically, that's a good practice to exaggerate a little bit. But don't exaggerate too much. 30% is a good value. So if I am running 1 day, ask for 30 hours, right? Give this 6 hours extra, right? Because maybe system is busy, maybe the node which you are running is in some kind of a trouble and it's slightly, its CPU is throttling or something like that, and you will need more time. So exaggerate with the wall time, 30%. But if you need a day, don't ask for a week. That's a waste of everybody, okay? So ask for 1 day, extra 6 hours, right? So that's the wall time. Number of resources which you are requesting, also very important. If you are using 4 cores, ask for 4 cores. Because if you ask for 8 cores and your code is compiled this way that it will be only using 4, this extra 4 cores will be sitting idle because they will not be allocated to anybody else because you have requested them, so they are allocated to you. And then, of course, you will suffer as well because we will charge you for the 8 cores, even if you used only 4. Okay?
So there are 2 questions. The first one is, how do I know when I need more than 1 node to calculate? My PA has not really talked to me about requesting more nodes, rather to request more CPUs.
SEF comment. SFF comment. That's slurm efficiency. Okay? And what is a good practice? I will talk about this in a second. What is also another good practice? I will talk about this in a second. Now, the other good utility is job arrays. I mentioned this very good documentation. So let's say something very repetitive, okay? It's the same program, the same structure of the code, but you are operating on different, basically, set of data. Let's say you are doing some analysis of the images. Index these images by, if you haven't indexed them, you can create a job array, and the index in this job array will correspond one-to-one to the data, to the image. And then you are submitting just one job, saying that I would like to run this job, but I would like to run this 100 times. That's the size of my job array. And the index of job array will basically be a part of my input file when I am reading the image. So job arrays, very good examples on our web pages and on the Alliance. And then if your workflow is constructed this way, that I need to run this simulation, but a simulation before has to be finished, look at the job dependencies. You can submit multiple jobs and build them into this submission of the multiple jobs, the job dependencies. So run job first. Don't start with the job number 2, even if this is in the queue, because I rely on the result of the job number 1 to be used as an input for the job number 2. Job dependencies, again, beautiful documentation. Okay.
2 more questions on Slido. The first one is there a command that summarizes how much resource were used for the job? So that is easy to adjust the sbatch command to be more mindful. The second question is, did you suggest increasing the wall time by around 30% per time?
Yes, 30%, that's a good value. Basically, you are not wasting too much. You are not being charged too much. Your job, basically, you have this margin of error, right? It's not like, okay, I am running a day and I am missing half an hour of the simulation, and right now I am frantically sending an email to the ticketing system. I need an extra half an hour of wall time. Can you do this in 15 minutes? And the guy is on the coffee break. He comes, the job is already gone. Okay, I'm sorry, I missed your mail. So no, this 30%, I'm answering this question once again, 30% exaggeration of the wall time, that's a good practice, okay? Don't be afraid of that. And the other one, yes, that's a save command, and I will be talking about this efficiency in a second, okay? Someone is reading my mind through Slido, I am afraid. Do you know who is doing this? Because that's the 3rd time. It's, I wanted to talk about this in a moment. Okay, so let's go, what is the best practice for the HTC job? So that's this high throughput jobs. And that's what I would like to talk about, this efficiency right now. So since this high throughput is typically a job which is running on a single node, make sure that you are using this node effectively. So make sure that your job is, if it's written for one core only, if it cannot use the multi-threading or anything like multi-core simulation, don't ask for the multi-core number. Ask for this how much. So read the documentation about the software which we are executing. And is there any kind of parameter to specify how many cores will be running this simulation? Typically, it can be OpenMP threads variable, which you can specify, but read the specific to the software you are using documentation about the multi-threading and number of cores which can be utilized. Let's assume that there is a parameter which allows you to specify this number of cores. Okay. And if they're saying, oh, it scales very well to, let's say, 20 cores. And you immediately ask for the 20 cores, because that's what documentation tells me, that for 20 cores, it's running okay. No. Run a short simulation with a smaller number of cores allocated to your HTC job, and then double the number of cores and see if your wall time between starting and finishing the simulation decreases by a factor of 2. If it decreases by factor of 2, try to increase the number of cores again and see how the scaling goes with your timing. If I am doubling something and I am shortening by factor of 2 my time needed for the computations, I am doing good. I am doing this faster every time. But at one moment, I can start increasing number of threads which I am throwing at my simulation, and my computational time doesn't change at all because I already flatten out. But I will be still asking for more cores and more cores. Useless, okay? Unnecessary. Okay, these are the HPC jobs. So that's for this small portion of the room, which is over there. So guys, for the MPI jobs, it's always good practice to ask for the full nodes, okay? And that's my only, let's say, plea to you. Ask for the full nodes, because if you are using full nodes, your results are always reliable and predictable, because you are not sharing a node with anybody else, right? If I will ask for my MPI program that I would like to have, let's say, one node, an MPI, the number of tasks, so MPI process is 30, I am leaving someone 2 cores to use them. And they will start some hogging program which will be doing very heavy I/O or something very, very nasty to the system, okay? Or maybe we'll be writing to the local disk so much that I will be spending time within a kernel to do the I/O for this guy. Ask for the full node, because then you always know that your job is reliably executing exactly the same time. So if something goes wrong, you will let us know, and we know immediately that we have something wrong with the system, because if your code is running 2 times slower than it used to run 2 days ago, we know that there is something wrong with us, not with you. So that's my plea for the for HPC jobs where you are doing this multi-node simulations that try to utilize full nodes.
There's a question on how do I request full nodes? What would I need to type in the Slurm script?
So when you go to the documentation pages and see how the system is compromised, typically, let's say on Sokai, we have a partition which is called Skylake and a partition which is called Cascade. And if you type, if you look at the documentation, you immediately know that partition Cascade, these are the Cascade Lake nodes which have 40 cores per node. Or if you will check what is the Skylake, it will be that's a 32 nodes. So depending on the top of the, when you read the documentations, you know how many cores is per node. And if your program can utilize this number of cores, ask for this number of cores. So basically, nodes equal 1 and CPUs per task equals 32. This will make sure that for your node, when you submit this job to Sokai, and you will put -- partition Skylake, you know that you will be utilizing the full node, okay? Oh, there is still a question.
There's one more question. So how can we estimate the right time for a job script?
Oh, that's a good question. I don't know. I don't know the answer. Right? That's an experimentation. That's an experimentation, right? So for this set of data, something is running for a week. For this set of data, it's running 10 days. That's trial and error, right? But if you are checkpointing, you can finally gauge this. But now, again, what is a good practice? When you are doing a checkpointing, you can always ask for the shorter wall time because you are checkpointing, so you can always restart. And typically, for every system in which I know, the shorter requested wall time always is reflected in the shorter queuing time. Because we always have a mixture of jobs. Okay, so if someone is asking for a parallel multiple run job to run for 24 hours, at one moment it has so high priority that I have to, as a scheduler, start stopping the nodes for doing other simulations because I would like to have this pool of resources for this big parallel job. But then if I am an HTC user and I am checkpointing, I can see that there is a multiple nodes available for a period of 2-3 hours. So if I want to ask for this 3-hour simulations, all these nodes which are right now waiting for some other nodes to start with the big parallel jobs can process my jobs. Yes, I need a day, but if I need a day, I will be waiting 2 days to start my simulations. I have 3 hours window. I will push everything by some considerable amount. Right, so the shorter wall time is always reflected in the shorter waiting time. So if I'm checkpointing, don't be afraid of correctly specifying the wall time. You will always do a few steps extra, right? Okay. Okay, in essence, my allocated slot was till 3 o'clock, but I am tired. I am really tired. But I still can talk, answering some questions from you guys or through the Slack.
There's a question.
So honestly, so let me just right now finish and then we will start. So we really appreciate your being here. We really appreciate people who are listening to us on Zoom. Because that's what we are for, okay? Without you, we are not needed. Okay, so if we would like to be employed, we need your input, we need something from you to give you either hand, or you give us the indication where we have to go with our next purchases, with our next infrastructure, okay? So as soon as we will stay in touch and not be afraid of talking to each other, asking questions, looking for the solutions. So let's stay in touch. Honestly, this is our email. A couple of days ago, I was giving similar presentation, and of course, I misspelled this email, and for the couple of days, we didn't get any email from UBC or Okanagan. This is correct email address, okay? Right now, it's correct. Okay, so thanks so much for this. This is our this survey, which we would like you to complete. And thanks a lot. If you would like to talk to me about anything, that's my UBC email. You can reach me either through the support list, but sometimes I can lose the ticketing system. But if you would like to chat with me personally, some questions, that's my email address. I will try to respond in a timely fashion. So again, guys, thanks so much. And right now, if there is any questions of Slido or from you guys, anytime.
So, okay, I just want to mention something very quickly about the survey. So the survey, for the ones that you have attended the previous session, it is a different link. And we do have different surveys for different courses. So please do ensure that you go to this link for this session. Otherwise, you will be responding, you will be providing feedback for Jacob, which is our previous instructor, instead of for Roman. So thank you so much. And I also want to, okay, so we do have a question in Slido. So the question is, are there any costs related to using HPC at UBC?
UBC services, UBC Sokai Chinook, and all the Alliance systems are charge-free. It doesn't cost you a dime, okay? You don't have to pay for that. This is, the only caveat is that in both cases, it has to be research-based. Okay, Digital Research Alliance of Canada, that's a CFI-funded project. And one of the conditions is that you have to do everything that has to be producing a research. And the similar with Sokai platform, we are funded by Vice President Research and Innovation Office. So again, our mandate is to support research. Okay, so as long as you are doing research, that's free of charge. But teaching, we cannot do that. And that's also with the alliance system a problem, right? Because basically free of charge under the condition that's research-based, okay? No more Slido. Let's kill the Zoom. Guys, thanks so much, okay? Thank you.
I just want to say one more thing. So we do have a lot of courses that's coming in the next few days. So do check our schedule and register. And the registration is still open. We do have a Ask Me Anything session on Friday afternoon. So if you have any questions about anything, like if you go home and think about like, okay, I should have asked that question today, feel free to register for Ask Me Anything and you can ask those questions on that day. Thank you so much, everybody.